Good day to Prof and Doctor. This is Group 8 presentation on the screening and ranking stage of the material for heat sink. For the function of heat sink, a higher thermal conductivity of material is desired as it is able to drain more heat away from the high power processing chip. Moreover, the coefficient of thermal expansion should also be low for the material. This is to ensure that the heat sink dimension doesn't change much due to the constant heating and cooling of electronic device as it is turned on and off constantly. The material should also possess high electrical resistivity as to avoid any electrical coupling and stray capacitance between the heatsink and the electrical component.
The three properties determined in translation stage are the constraints for material selection. The value of these three properties were determined by referring to the property values of aluminum alloy 6063, the most common used heatsink material. Thermal conductivity of aluminum alloy 6063 range from 201 to 217 watt per meter per degree Celsius, whereas its CTE and electrical resistivity are 23 times 10 to the power of negative 6 per Kelvin and 0.035 times 10 to the power of negative 6 ohm meter respectively. Referring to these values, the values to be used in material selection were set as shown in Table 2. Thermal conductivity equal to or higher than 220 watt per meter per degree Celsius. CTE equal to or less than 23 microfarad per degree Celsius. Electrical resistivity equal to or higher than 3.5 microohm centimeter. After setting the limit, screening was performed. First, the initial screening was done using Level 3 in Granta CES EduPack 2019 software. The SP chart of thermal conductivity versus CTE was plotted and the limits for these two properties was set, followed by setting the limit for another constraint, which is electrical resistivity. There were 14 candidate materials left as shown below after this initial screening. Next. This figure shows the result of initial screening where the 14 candidate materials including diamond, few types of graphite, carbon, few types of beryllia, which fall under the classification of technical ceramics. Also, there were beryllium aluminum alloy, coated copper lead coated, copper cobalt beryllium alloy, and palladium copper alloy, which fall under the classification of metals and alloys. These 14 materials will then undergo the go and no-go screening. Next.
Okay, now we proceed to go no-go screening. This is performed after the initial screening where we obtain the 14 candidate materials before we start to ranking. We read it as satisfactory and also unsatisfactory. The unsatisfied properties will be eliminated. We screen it based on three properties where corrosion resistant because because the heat sink is constantly contact with the fluid medium for the cooling process. Then availability in large quantities where to meet the demand of rapid growth in electronic industry. And lastly, workability, which directly impact on the strength, quality, appearance, and also the cost of labor. Then we proceed. We proceed to the table 3, where we have done the go no go screening on 14 candidate material. As you can see, the first properties corrosion resistant. All the candidates are satisfied. Then after we move to availability in large quantities, the diamond is unsatisfied. So the diamond will be the first material that will be eliminated. Then we proceed to workability. Workability, as you can see, Beryllia 99, Beryllia B 995, Beryllia BZ, and also Diamond will be eliminated. As you can see, all the red color is all the material that we will be eliminate, and the aluminium alloy 6063 is the commonly used heat sink material in nowadays. So the green color is what uh, what the candidate that we wanna use as our team project. Thank you.
So these are the properties that our group consider in ranking, which are density, cost, thermal conductivity, and maximum service temperature. For density, low density is preferred to reduce the overall weight of the device. However, this property can be compromised by having a good design for weight reduction. Next is cost, because we need to reduce the overall cost of product. For thermal conductivity, we need high thermal conductivity because it is important to conduct more heat away from electronic device to cool the computer. The last one is maximum service temperature, which is the heatsink can be used for an extended period at high temperature without significant problems such as oxidation. These values are for current material, which are aluminium 6063 based on the properties. Next, we calculate the weighing factor by using digital logic method, which we compare each of the properties. For example, 2 possible design combination means we compare property number 1, which is thermal conductivity, and property number 2, which is maximum surface temperature. And from here, we consider thermal conductivity is important than maximum surface temperature. Since we have 4 properties, so we get 6 possible design combination. So we compare all the properties and we get possible decision for each properties, and then we calculate weighing factor by divide the number of possible decision with total number of possible decision. From here, thermal conductivity have the higher weighing factor, followed by maximum surface temperature, density, and the last one is cost.
So the second stage in ranking is weight property index method. In this method, we first need to calculate the scaling factor. For properties that higher value is preferable, that is, in our case, thermal conductivity and maximum service temperature. The scaling factor is calculated by using the numerical value of property divided by the maximum value in the list and then multiply by 100. For properties that lower value is preferable, that is, in our case, density and cost, the scaling factor is calculated by lowest value in the list divided by the numerical value of property and then multiplied by 100. And then finally, the weight property index is calculated by the sum of multiplying the scaling factor with the wedging factor that we calculate in stage 1. So next, we substitute the values of properties into the equation just now, and we calculate for the weight property index. Notice that we also add in the aluminum alloy 6063 as comparisons to the other material we found in screening. And then we get the highest weight property index for graphite pyrolytic 2.06 parallel to plane. And this material has the lowest density and highest maximum service temperatures compared to other material, although the thermal conductivity is slightly lower than the coated copper lead coated, but the other two properties are far more excellent than others material. So we will choose this material to make our heatsink.